Hey everyone, this short presentation will capture most of what you're going to need to know regarding energy efficiency in general, and then specifically pertaining to vehicles for Chapter 17. So we're going to start out with a look at a house built in Colorado. So this was built in 1984 by Amory Lovins, and it might seem like an ordinary house, but it's actually far from it. So this house is way ahead of its time, considering it was built in the 80s. And it runs entirely on renewable energy. So that's including mostly solar power, some solar heaters, and in combination with super insulation. While most of us spend about $50 or more a month on our energy bills and heating bills, this house actually only spends about $50 a year. In addition to solar power, another power that's really taken off is wind. And this is a photo from when I was traveling in Spain. I was riding on a bus in the country, and stretches and stretches of the highway, you would see these wind farms. You'd also have solar panel farms also. Many of the European countries have already embraced solar and wind power. And the reason is really easy, because they can save a lot of money and depend less on foreign countries. So the term conservation is used in environmental science all the time. Most people don't exactly understand why, because of the physics involved, though. So this is where we take it to the next level for AP. We've discussed and we've talked about the second law of thermodynamics. And if you think back to which unit that was, I'll give you a minute. Hopefully you're thinking food webs and trophic levels. And it has to do with the second law of thermodynamics. So this is the law that explains that every time we transfer energy from one form to another, we lose a little bit of energy in the process. So when you think about your breakfast today, let's say you ate some banana chocolate chip pancakes. These food calories get stored in your body so that you have the energy that you might need to, let's say, go for a hike at Hawk Mountain. But when you begin your hike, your body starts to take those chemical stored energy calories and turn them into mechanical walking energy. And that process of actually changing those calories into a usable energy, so from the chemical storage ones to the mechanical ones where you're actually working, you're losing some fuel in the process in the form of heat. So your body's not 100% efficient either. In terms of things that we use on a daily basis, like our cars, they get an average of about 41% of wasted energy every time we use them. So there's two major ways that we can focus on improving our conservation. And the first one is to use less, literally. The second one is to improve our efficiency. By using less, that's just like turning off lights or unplugging things when you're not using them. We can improve the energy efficiency of machines. So if you look on like perhaps your washer and dryer, you might see a little Energy Star symbol. That indicates that it's energy efficient. And the leaders in using less and actually harnessing these renewable energies would be Japan, followed by France and Germany. And we actually fall somewhere in the middle of that spectrum of using renewables. So we, as Americans, have some steps to take. So improving efficiency, I just wanted to make a quick note. Efficiency is calculated from 0 to 100. So we know it's normally a percentage value, and it won't ever fall below 0 or above 100. So as far as improving efficiency, it's with this next